runtime and compiler and language designer personal interest of mine. I'm making minor contributions to the mypy project itself, and I'm doing that as part of my job at Machinalis, which is a Python Django development agency. We provide great teams to people, and we starting to use mypy, and it's been a lot of fun and very useful. So my goal for this talk is to give you some ideas of why you might want to use this kind of tools. So a very, very short story is that mypy is a static type checker for Python. That means that you grab your Python code, you add some type annotations, which is like labeling arguments and functions to saying which types they are, and you run this mypy tool on your code, which gives you warning about where your annotations are not consistent with your code. So you write code something like that. The light blue underline things are the annotations, and you install the tool and run it, and it gives you nice error messages pointing to where the problem exactly is. So if you find this amazing, you can learn more about this at the Python Enhancement Proposal 484, where defines how the annotations should be written and what they mean, etc. The mypy documentation is quite good. PEP 483 gives you a little more of a theoretical background, and even the 482 have some library documentations. So I'm glad you're happy. Thank you very much. And well, if you're not convinced yet, I may talk a bit more about this. So, why are we interested in static type checking? Let me give you, I don't want to bore you with theory, but there are a few misconceptions around this. So just a single slide, let me. What's a type? People call types very different things, especially when coming from the Python background. Sometimes we think of the type as a runtime structure containing the methods and information about how to dispatch function calls on an object and stuff like that. Or if you come from the C side, you can think of a type as a memory layout for storing objects, which that's a structure. But other meaning of types is thinking about labels, like some kind of useful information that you can attach to a small piece of source code. A small piece of source code that denotes an object. It's used in other different meanings, but what we'll be talking in, at least right now, is these label things, these pieces of information, which cannot necessarily be structural information. So why you might want to do it? Well, the first thing is that if you find a tool which is called a static type checker, the checker tool might give you a hint, and you think, oh, this is a tool for finding bugs. And well, more or less, it's useful in the sense that Python actually doesn't let any type errors go through when executing. It's very lazy about detecting type errors. It detects it right at the moment when you're running your code and the type error is found. So it's good to detect errors earlier. Most of the types errors you'll find in actual code, normally while you're writing the code, are quite obvious. There are a few that aren't, but I'll say that 80–90% are quite obvious things. But in any case, if you have good tests, most of these kind of things will actually be detected by your tests. So checking is nice, is useful. It's not the most important thing of this. In the little practices that I have had with this tool, what I found best about the checking part is while I'm writing the code, especially if I run it very, very often, every few lines of code, I can detect very simple typos or mistakes that I did, sort of like the kind of things that you find with Flake8 or Pyco style or stuff like that. right away instead of having to wait until I run my test, which may take a lot longer. So development time it's quite useful. But in any case, given that we're talking about tests, most tests that one writes are not written specifically to detect this kind of type errors. So you might get, when running your test suite, error messages that are not directly relevant to the problem that you actually detected. You're trying to focus on more functional style things in your tests. So you could add tests for every function, but it would be quite cumbersome. So you can think of these kind of annotations like a very small and practical and simple way to write domain-specific tests. So if checking is not the real reason or the most important reason, which one is it? The most important reason is readability. Annotations are labels that you put in your code that specify the author intent. The author of the code was thinking about some specific use for this argument, for this function, and annotations allow you to specify and communicate that. So it's like a docstring, but the difference with the docstring is that you can actually validate that this intent actually matches what the code does, which is quite important, because documentation tends to be outdated. You forgot to document some arguments, or the type of an argument is changed, but you don't have updated documentation. So that's nice. So in that sense, it's more like a doc test, which is something which is documentation, but you can actually execute and validate. But unlike a doc test, it's also very small and compact, and that's a nice part of it. So it's actually, I found it very useful also when refactoring. Again, you need tests, and if you're doing refactoring, they will help you a lot. But what I found is that like 80% of the silly mistakes I do during a refactor, I detected by the type checker. And while the rest are 20%, I have to run the test suite, wait until it finishes, try to debug and understand what the test messages mean about my code and figure that out, but it's a lot less work. So Angela already mentioned this, and it really helps a lot. And in general, when you are looking at the code, understanding a few tags with a standardized and formal notation about what the result function of this is much better than having to read two pieces of documentation like this that you can find in the official Python documentation. So something else that I found almost accidentally is that is very useful when exploring legacy code. I have a bunch of code that I didn't write, someone else wrote, and I don't know nothing about it. My first experience was actually trying mypy by doing this, and I found it very useful, and in some way it's like learning by explaining. You're explaining the type checker what each function takes and returns, and you begin to understand in a much better way how all the pieces connect to each other and which parts depend on each other. And also, you're not only trying to do nice guesses, which is something that you could do without a tool, but you are also validating those guesses around the actual code and seeing that your assumptions are actually true. There are other reasons why you might be interested in this, which are also secondary reasons, but may become important in the future, I think. Integration with code editors, like providing nice completions, go-to-definition functions that work better than now, automatic refactoring tool, documentation generators. Some people are talking about using this for optimization. It may or may not work, but it's there and it's a possibility, so that's quite nice. So after discussing a bit about the whys, let me talk a bit about why now. If this is such a good idea, why now and not 25 years ago when Python was released? Well, the idea has been around and discussed for a long time. I could find a written record at least in 1999. Probably it has been discussed before by people leading the development of the Python language. But at some point they decided, well, we need some language support. We haven't decided yet how this would work, but we will add some baseline, which is PEP 3107, which is introduced in 2006, and Python 3.0 released later included that. But mypy appears sometime around 2013, especially mypy as a static type checker, and provides a standard and uniform way of using these annotations. Before that, annotations were very hard to use because they are supposed to be an interface description tool, but an interface description tool without standard is not very much useless, because if everyone is annotating their interfaces in a different way, it doesn't help. So at some point, PEP 484 standardizes mostly what mypy has been doing with a few changes, and that got included in Python 3.5. So the good news this year is that in 2016, mypy got included into the umbrella of official Python projects, and there's a huge push from the people at Dropbox who are working on this, and Guido is directly involved with this, if you look at that. So it's really have an important base of support that wasn't there before. A lot of people are very worried about this or scared about this. So an important thing to consider is that even if there's a way to abuse this, and there's a way to abuse a lot of things that Python does, and you can see a lot of funny lightning nodes doing interesting hacks, the Python community is a community who cares a lot about readability. Readability counts according to the sun. So if you think about it, it's not probably something that will ruin the language as so many people are scared about. Actually, the thing is, not many people have used these languages on both sides, so you hear people from the statically typed language camp that have used dynamically based language very badly and don't know what are the actual advantages of being dynamical, and people coming from the dynamical science, dynamically typed side, also worried about bad experiences with bad statically typed languages. So let me talk a bit about what's different in mypy with respect to more classical approaches. There are a couple of big misconceptions around. One of those is that static typing is equal to explicit typing, having to write down the type of everything everywhere. That's actually not true. A lot of statically typed language are able to infer the types of most of the tiny details and irrelevant things, so you only have to specify the types of the things that you actually want to declare the type of. And mypy goes into this line. It forces you to just use annotations in the interfaces that you care about to describe, and not, for example, for local variables mostly. We'll talk more about that later. Another thing is that most classical statically typed languages have mandatory static typing. So you write your code and you have to convince the compiler that you don't have any kind of type problems that it could detect, even if your code may be right, or even if some piece of your code may be right, before you can run the first line of code. And this can be quite different. This can be, again, like unit testing. I can have a test suite and have a couple of tests fail, and I still can run my code and use it. Some things may be broken, probably, if some test fails. Perhaps the tests are broken. But it works. Even if I know it's a small piece that is not important or not critical, I could even release it to production. It may not be a good idea, but if I want it, I can do it. So how does this work? How does this non-mandatory typing work? Well, there's a small trick around. It may be like a little technicality, but bear with me for a second. Python is already a typed language, because in Python, everything is an object. And everything, if you look the implementation of CPython, everything is actually a PyObject pointer when you see it in C. So there's this single large type that is able to do everything. You can call it, you can index it, you can find attributes in it and figure out if they are there or not. And well, you can say that Python has a single type. Standard Python has a single type, which is a single label, which is something that I can say about every single Python object. And we can call this any. So I could write code like this and tag the types and arguments of function as any. But according to PEP 484, that's actually the default. So that's equivalent to writing exactly that, which looks a lot like Python, and that's Python. So that's a correctly typed Python program, no matter what I give to that. And that's a correctly typed Python program that does exactly the same everything that the Python program you know, because that's Python. So the idea behind this is it's called gradual typing. The important part of this is that you can use type annotations only if you want it, only where you want it, and you can mix up annotated code and non-annotated code freely. And it doesn't matter on runtime because this has nothing to do in runtime. This is checked by a separate tool that you run it when testing on your continuous integration server or whenever you like while you're developing. So for example, you can see 2 copies of the same function and some examples of what you can do and what you cannot do with it. So regular calls, like the first 2 ones, are okay. They're the same function. The second one is annotated. That's the only difference. The second one is also accepted because that function takes, the dynamic function takes an any, so I can pass it strings, and strings are any, so that's okay. And one of these calls actually works and returns something, which for the static checker is guessed as an any because D has assigned the result of the function which returns any. And one of the interesting parts of this is that I can call the static version of the function, which accepts ints, and give it any to it, and the type checker will accept it. That's very subtle, but it's important. The static checker realizes if I pass an object that it's not an any, but it's something that it knows to have a different type, like a string or something else. So that's really nice. So you can annotate everything as any, but you are not given any interesting or useful information because the any type tends to be contagious. You start returning any, so that gets assigned to your variables, and they get any as value, and you pass them around, and that information is lost. So it's much better if your code and your libraries are annotated. And most libraries right now aren't annotated, except for a large part of the standard library. So you can write these kind of files which are called typestabs or typestabs, which are special Python files when you only put the signatures of the function you're interested in, or the description of the classes, and you can use those as type annotated version of a real actual library with code. I'm actually working in writing a couple of those typestabs, both for NumPy and for Django, which are tools that we use a lot. It's not too hard to do that. There are some interesting tricks that could go into a whole another new talk, so I won't go further today. To give you a bit the other side of the coin, there are some possible problems that you can find or you can struggle with when you start to do this. If your code is too dynamic, don't use it. Sometimes describing the types for a very polymorphic, dynamic, flexible API is quite hard, and you end up saying, well, this argument is an any, and that's okay. That may be better than giving a very huge type annotation or very complicated and hard to understand. The idea is making things more understandable, not more complicated. If you use tag typing, well, Angela mentioned something about this. There is some ad hoc support for some very standard duck types in Python, like the iterable protocol, the mapping protocol, the sequence protocol. But for your own classes, if you use duck typing a lot, you need to use some trick right now. I understand that's planning. There's a fix for that in planning. And you might have a lot of problems, not serious problems, if you depend on a non-support library in a library which doesn't have typesets. Essentially, if you don't have typesets for a library, every function in that library is assumed to be of any type, so it can be called with any number of arguments and indexed and returned and that's contagious. But you can annotate actually things anyway that you give to the library, and they won't get any checks on runtime, so when the library gets support later, you may find some problems there, especially if they define the interface in a different way, but that will work. And there are a lot of tiny paper cuts and minor fixes that could be fine. I wrote a very lengthy article about some experiences with a lot of tiny details. A large number of the things that I put down there, this was a couple of months ago, and they have already been fixed. So the project is very active, it's improving very quickly, and that's really nice. You see how it changes, that each release has a lot of new things and fixed things and works a lot better, so it's really nice. So to summarize a bit, there are many good reasons to use it. You really should try it. When you use it, your code gets better. I didn't mention this, but actually annotating a legacy code base got me to find out many situations where the design was too complicated to annotate, and actually that was because the design was too complicated and could be made simpler, and it helped me detect some code smells. And you can choose how much you want to use it, and that's really nice. It works better if your library supports it, so that is a large place. There's large room for improvement there. And the benefit you get might depend a bit, depending on how much, how dynamic is your code. So that's all I have for this time. I'm willing to talk a lot more about this if you want to discuss later, so please find me around. Thank you very much. That will be all.
So we've got 5 minutes for questions.
Sorry, you can time me there, obviously.
So we've got 5 minutes for questions. Can I get people with questions here, please? Have a question? Yes.
Hello. You say you work with mypy people and so on. I've been working on a plugin for Vim 8, which takes the text you have in your buffer before it's been saved to disk.
Can you speak a little bit slower?
Sorry, there.
Thank you.
I've been working on a plugin for Vim 8, which takes text that you have in your file buffer before it's been saved to disk, and then puts it through linters. So it works with Flake8 and ESLint now. If anyone's interested, you can Google lint while you type in Vim, and you'll find it. Could it be possible to add an option to mypy to read from standard in as well as from a file?
I guess, yes. Evidently, it can be added. It's Python code, and it's quite easy to work in, actually.
You can pass on a message that you...
I don't know if it's planned, because I'm not one of the core developers, but there's one around. I don't know if he wants me to point in. So probably he can answer that better.
You can pass on a message saying that you met some weird guy. Yeah.
Hi. If any means object, why isn't it called object?
Well,
What's the subtlety here?
There's a slight difference. So everything is an object and everything is an any. But the label any means I can do anything possible with this, like any Python object. The label object means I don't know anything about this except that it's an object. So you can do anything on any, like accessing any attribute or call it or index it or add one to it or whatever. Well, on an object, you only can access whatever the object class has, like the dunder class attribute, or use it on an if condition. You can only use it for very basic things if something is declared an object.
Could you tell us a little bit more about duck typing and also how you think duck typing might change in future?
About how?
Duck typing.
Yes, a little more about the typing and what?
How it's being supported and how it might come to be supported.
Okay, so yes. Duck typing right now is somewhat described in the PEP and in the typing module, but it's not completely supported by the tool. So the idea is that you can define a class inheriting typing.protocol and add some methods to it, only described in the interface. And if you have a class inheriting that protocol and you declare an argument or return value as that type, it should be supposed to accept anything that conforms to that protocol. And that should be the way to do it. Right now, this works for very standard protocols in the standard Python library, but not for every possible protocol that you could imagine and invent and write yourself.
Can that include exceptions that things throw in that?
None of the specification for this covers what kind of exceptions are returned. It's not like Java in that sense.
Right, thank you very much, Daniel.
Okay.